God morgon alla sammen. Välkommen till detta webbinar i samarbete med Panduit. Strax etter vi er ferdig, så åpner vi for spørsmål. Enten jeg har lyst til å stille dem direkte på engelsk, eller har lyst til å ta dem på norsk per tekst, eller til meg direkte, så kan jeg fint oversette til engelsk i etterkant. Jeg kommer nå å switche til engelsk og overlate ordstyret til Simon som skal kjøre presentasjonen. So, welcome everyone, and Simon, you're very welcome to get started.
Thank you, Nicholas. Thank you, Nicholas, and thank you everyone for joining. I am Simon Westwood, the Technical Systems Engineer for Panduit, and I've been with Panduit for 25 years now. Today's presentation concerns Panduit cable cleat solutions for short circuit protection, and specifically, are you fully confident in your short circuit protection? So the goal of the presentation today is to explain what is a cable cleat, why are cable cleats necessary, to help you understand what the effects of a short circuit event are, to explain that faults do actually happen in the field, a quick discussion on the applicable standards and type approvals, and then a review, finishing up with some questions at the end. So very briefly about Panduit, we're a privately held company with in excess of $1.2 billion worth of sales now, and we hold more than 2,000 patents, and this just underlines that Panduit is an organization of invention and innovation. To give you an idea, this is Panduit's research and development department in the United States, and the reason that we spend so much time and money on innovation and invention is because more than a quarter of our sales come from products we deem to be new products. That's products that have been introduced in the last 5 years. So, to begin the presentation, what is a cable cleat? And quite simply, according to the relevant standard, which is IEC 61914, the 2021 version, a cable cleat is quite simply a device designed to provide the securing of cables when installed at intervals along the length of cables. Now, traditionally, people think of cable cleats that look like this item here, a stainless steel trefoil cleat, or this item here, or this item here. In actual fact, every single thing that is on this page is classified as a cable cleat, because remember, it is simply a device designed to secure cables, and that includes Panduit's double wrap stainless steel cable ties. So why are cable cleats necessary? And rather than getting too technical, along the right hand side with this graph here, all you need to know is this these large waves that you see here, and this basically indicates that during a short circuit event, the maximum electromechanical stresses and forces between the conductors occur in the first 5 to 6 thousandths of a second. And the reason that that is important is because typical circuit breakers and other protection devices trip and interrupt a fault in the first 600ths to 1/10 of a second. Now remember, cable cleats perform their function quicker than that, approximately the first 5 thousandths of a second. So by the time the circuit breaker kicks in, all of the maximum forces have already been exerted. To give you an idea of a short circuit event, This is a short video filmed in slow motion, and this is a typical test setup. And you can see here that cable cleats have been installed every 300 millimeters along the length of this ladder rack, and they're installed on every single rung. And what happens during a short circuit event, particularly when you have a trefoil arrangement of cables, is that the cables in effect react with each other. The copper cores of the cables react against each other, and they try and get away from each other as quickly as they can. So in effect, the top cable will shoot in an upward direction because it will try and get away from the two cables below it. Likewise, the cable this side that you can see here will shoot off in this direction because it's trying to get away from the two adjacent cables. So this is an idea of how the cables try to get away from each other. And during a test, what has to happen is the cable cleats have to, first of all, contain the cable, but secondly, not damage the cable. To give you an idea of how strong these forces are during a short circuit event, this is another test setup. And again, a cable cleat has been installed every 300 millimeters on every rung that you see here. And what we've done in this situation is to show you what will happen when the cable cleats installed are not strong enough to withstand the forces that are exerted by this short circuit event. So what you will see here in this video is the cables will try and get away from each other, and they will fly off in different directions, and the cleats installed are insufficiently strong to contain the cable. So I'll just run the slow motion video. And if you pay particular attention to the cable cleats, you will see that as the forces are exerted, the cable cleats break and fly off in different directions. Now, obviously, this is a hazard for anyone in and around that area, but also it is a hazard for the cables and indeed the ladder rack. If you're to look at the ladder rack, you can see here the amount of deformation that occurs on these rungs, and I think one of them here is actually broken away from the side wall of the stainless steel ladder rack, and you can also see the amount of damage done to the walls of the ladder rack, never mind the cables that have flown off and the cleats themselves. So what we have in this next video is typical competitor cleats that have been installed on a test bed, and this kind of gives you an impression of not just the violence, but also you can see here the sparks that are flying as well. So when a short circuit event occurs, you can see the effects of it, and in many situations, this is particularly undesirable. So one of Panduit's solutions to this is to use stainless steel straps or stainless steel cable ties, both of them double wrapped. And the question that we're often asked is a strap or stainless steel cable tie as strong as a traditional cleat product? In the bottom right-hand corner, you have a traditional product, and all of these tests are done using the same size cable and the same peak current in terms of short circuit. If we can just go to the first video, you can see that is a stainless steel strap that's being used. You can see the level of bowing that's taking place with those cables, yet they are still contained, and safely so. In the bottom right-hand corner, you can see polymer cable cleats and the effect of that short circuit. And on the left-hand side, you can see here the cables flying apart in different directions, but because of the Panduit stainless steel straps, they still remain contained. So do faults ever happen in the field? What we have at the bottom, 3 images here, is quite simply somebody working using an excavator, digging into the ground, probably to put some pipe work in. And what happens in those 3 images is, first of all, they're dug into. Secondly, the bucket of that excavator hits a series of cables and creates what is in effect an explosion. You can see the reaction of the 3 guys stood nearby, and that is potentially a very, very dangerous hazard. In effect, it's caused by that, what I refer to as metal on metal contact, which is the bucket hitting the cable. To give you an idea of a couple of other examples here, the central one is pretty much what happened in that first event. This one over here shows on an underground metro system the use of J-hooks that have corroded, and they've corroded into the sheathing of the cable. Eventually that will lead to metal on metal contact and a short circuit event. This one, I believe, shows multi-core cable, and what's happened here is that rats have eaten through the sheathing of the cable, leading again to metal on metal contact, and when that occurs, a short circuit event can occur. And this was potentially the most hazardous, which is some maintenance work has occurred, and what's happened is the maintenance guy has lifted these cables out of this saddle and rested them on the threaded rod that you see here. Those cables were forgotten about and never returned to the cable cleat that was holding them, and the effect of that was it caused a short circuit some 15 meters further down the track and led to a potential hazard, but thankfully with no fatalities. Another simple image here shows the breakage of cable ties that we use to try and hold the cables in place in the event of a short circuit, and the strength of those ties was insufficient to control the level of damage by that short circuit event. So when we look at approval bodies or regulators, such as DNV, ABS, UL, they do give some guidance, and what they say is things that are fairly vague, such as when installing cable cleats, you should look to prevent excessive movement, to withstand repulsive forces or withstand magnetic forces, and hold the cables together during a short circuit event. They'll say things like it's important that the cleats are selected, performance tested, and installed with care, but it does not tell you how to select them. It just tells you that due diligence is required. So we've called this the midpoint summary. It isn't quite the midpoint, but what we've learned so far is that a cable cleat is simply a device designed to provide the securing of cables when installed at intervals along the length of a cable. We know that correctly engineered band and strap product is every bit as capable of competing with a traditional cleat or a more traditional cleat. And we know that all of the major activity occurs during the first 5,000ths of a second. We understand that faults do actually occur in the field, and we know that the various bodies that exist require due diligence and the correct specification, but they do not dictate how that happens. So in terms of questions, do your methods of cable fixing comply with the legislation? Will your fixing methods retain the cable securely in the event of a fault? And most importantly, how do we make sure that you can answer yes to both of those questions? The answer to that is using the correct standard. And the correct standard, as I mentioned before, is IEC 61914-2021 cable cleats for electrical installations. Now, IEC 61914-2021 is the third version of this standard. The original was 61914-2009, and that was updated in 2015. And the most significant change from 2009 to 2015 was that the 2009 version didn't specify the range of cable diameters to use in a short circuit test. So previously, manufacturers could test larger diameter cable to improve the perceived strength of the cleat. Now that sounds slightly counterintuitive. One would imagine that using bigger cable would lead to bigger forces. In actual fact, what happens is the larger the cable, the further away from each other the copper core centers of the cable are. So it actually reduces the forces exerted on the cable cleats. So the 2015 version standardized the test cable diameter range. So manufacturers' test results could be properly compared with each other, and it limited the possibility of manipulating test results by using larger diameter cables. IEC 61914-2021 also tests for a number of other things, such as corrosion and UV resistance, impact resistance, lateral and axial load testing, resistance to flame propagation, and temperature ratings. Now, cables can be formed in a number of different ways. They can be a single cable formation, a trefoil cable formation, which is in effect one cable on top of two cables, or even a quadrifoil formation, which includes the three phases and neutral or earth. The benefits of Panduit's version of short circuit protection is the innovation of using stainless steel straps and ties. So first of all, it's worth mentioning that the straps and ties are IEC 61914-2021 approved. And quite simply speaking, those solutions are up to 50% quicker to install than a traditional cable cleat. They're also up to 50% cheaper than using traditional competitor cleats. Other benefits include the weight saving, the application space saving. And when I say the application space saving, if you look at the image on the right here, you can see that there are 5 banks of trefoil cables arranged here, and they can be fitted into the ladder rack that is this wide. So they are able to populate more banks of cable in this width of ladder rack than a traditional cleat, which would have to be fixed here and here, for example, which means the next time you try to fix it will be here and here, which means that in reality, you could probably only get 3 banks of cable into that size of cable containment. So Panduit is a space saving in the application. Additionally, if you were to buy, let's say, 1,000 traditional cleats, it would probably take up around 3 pallets worth of space in terms of storage space. Buying 1,000 Panduit stainless steel straps or ties take up less than 1 pallet load. Additionally, when we spoke about the arrangement of the cable, be it single, trefoil or quadrifoil, Panduit stainless steel straps and ties are bundle conforming, so they can fit any shape that you want them to, whereas traditional cleats have a fixed shape. You will buy a single cable cleat, you will buy a trefoil cable cleat, or you will buy a quadrifoil cable cleat, and it can only be used for that purpose. As I say, the stainless steel straps and ties from Panduit are bundle conforming, so it doesn't matter what the arrangement of cables are. And finally, they're range taking. when you buy a traditional cable cleat, they are designed to fit a specific diameter of cables only, whereas with the Panduit product, if you use a stainless steel tie or strap and you want to use larger or smaller diameter cables, you just change the length of cutoff. So in summary, the benefit of using Panduit short circuit protection is, very roughly speaking, half the cost, half the installation time, half the storage space. As a value proposition, that is a very strong argument. Half the cost, half the installation time, half the storage space. In addition to doing traditional testing, as you saw earlier on those videos, Panduit has developed a simulation program. And when we talk about a simulation program, this simulation program not only looks at what we refer to as the physics of the cables during that short circuit event, it also looks at the magnetic field vectors within it. The more and more we test for short circuit protection information, the more information we feed into that simulation program. And again, when you look at this short circuit event, this is conducted at a third party, and that third party is KEMA. It is an approved test house. And the more information, again, the more verification data we get for it. And you can see in those cartoons, if you like, that exactly what is going on in reality is going on during our simulation program. In addition to conducting those simulations, we also conduct what's referred to as intentional failure, which is to ensure that the information that our simulation program is providing is very accurate. So if you watch this video, you will see here, for example, that during our simulation program, and I think it's on this side here, the breakage of the cleat is expected to occur here. So what we've done is we've completed all of our testing, and then what we've done to prove our simulation program is to put slightly more forces or exert slightly more stresses on these cable cleats. It's called an intentional failure, and what it shows here is where this break occurs is exactly where the break occurs in reality. Likewise, on the next video, you will see that the breakage occurs at the bottom in the saddle, and that's exactly where the breakage occurs here. So these are intentional failures, again, designed to validate that simulation program. In addition to the failures of the cleats during those intentional failures, the simulation program is so accurate, it doesn't just look at the breakages, it also looks at the fastener thread induced damage. So our simulation program has predicted this, and this is what happened in reality, and that would be a fail. So our simulation program is really very, very accurate and indeed award-winning, best in show for commercial. So there are two ways of testing: the third-party testing that we've spoken about so far, the simulation program that I've just covered. The third way of testing is using a mathematical formula. Now, you don't need to understand this mathematical formula. You just need to know that we understand this mathematical formula. And what this calculates is the maximum forces on each individual cleat. And it's measured in newtons per meter. And this mathematical formula requires the peak short circuit current, the distance between the two neighboring conductors. And when we talk about the distance between the two neighboring conductors, what this equates to is the outside diameter of the cable. And to very quickly give you a rough idea here, what we're looking at is the peak current is 75.1 kiloamps in this particular case. The diameter of the cable is 38 millimeters, and using that formula, we are able to say that the forces exerted are 25,000 newtons per meter. So if each cleat is installed at 300 millimeter spacing, such as every rung on a ladder rack, that becomes 25,000 multiplied by 0.3, which means that each cable cleat must be able to withstand 7,500 newtons per cleat. Now, previously, what had to happen was the end user would have to come to the Panduit distributor and say, I need a bunch of cable cleats. And the distributor would come to Panduit and say, we need a bunch of cable cleats. And Panduit would go back to the distributor and say, okay, we need to know some variables in order to be able to calculate which particular solution you need to look at. And typically we need to know what the peak short circuit fault level is in kiloamps, what the outside diameter of the cable is in millimeters, and potentially what the spacing between each fixation point is. And those are typically calculated in multiples of 300 millimeter spacing, because the rungs on ladder rack are typically 300 millimeters apart. And that process could take a very long time, from end user through distributor, through Panduit, to our engineering team, back to Panduit, back to the distributor, all the way back to the end user, and eventually that information would flow through. So that information could take in the region of 1 to 2 weeks to work out which particular cleats need to be used. Panduit has a cleat calculator app now, which is available on the Panduit website, which means that instantly you can get this information, whether it's for a trefoil cable layout, whether it is for a flat cable layout, such as this one here, or even if it is for a multi-core cable layout. So Panduit has this cable cleat calculator. And to give you an idea of how this works, all I have to do is select my cable arrangement. I then have to put in details of the cable diameter, and I'm just going to make something up here. 50 millimeter cable diameter, 75 kiloamp peak current, and then I click on find the cable cleats, and what you will see here is it will give a number of different solutions that can be used, and all the end user has to do is select the optimum solution for his application. If space is a concern, for example, go to the smallest solution that's available here. If cost is a concern, go to the cheapest solution that's available. And you can see here that it will recommend usage, whether it can be used at 300 millimeter or 600 millimeter, whether it's past third-party testing, or whether it is simply calculated and using a simulation program. If you can use it at 600 millimeter spacing, quite simply speaking, all that means is you need to use half as many as if it was used in a 300 millimeter spacing. Due to the nature of Panduit stainless steel cable cleats, some people think they know how to install it in a very straightforward manner. However, this is not the case. They do have to be installed in a specific manner. And what you'll see here is a non-compliant installation that a contractor actually tried. So first of all, there are a number of things wrong with this installation. Firstly, as you can see, the straps have been installed diagonally across the cable. This is not how it should be installed. It must be installed completely perpendicular to that cable. completely parallel to the run of the rung that's holding it in place. Secondly, we were able to ascertain that these cable ties are double wrap cable ties, but they had only been looped once through the head of the tie, which means that they are non-compliant. Next, the installer failed to install cushion sleeving on the inside of those cable ties. And finally, and I don't know if you can see here, they actually used the wrong installation tool, which led to a sharp cutoff. This is the correct way of installing them. And as you can see here, what we have here is stacked levels of ladder rack with multiple cables installed along the way. I mean, first of all, it looks very, very neat. The image I showed you earlier also shows the use of a bracket. So where the cable tie is unable to fit through the slots of the rung, Panduit has a bracket that allows the cable tie to be installed completely perpendicular to the cable and parallel to the rung itself. You can see that there. It's also worth noting that you do not need to install a bracket on every single rung. You can install it on alternate rungs and use a stainless steel cable tie to hold this cable in this position as well. Finally, you can see here the bundle forming formation of a quadrifoil formation. And this cable tie can be used around single cables, trefoil cables, and quadrifoils. And remember the benefit: half the cost, half the installation time, half the application space here, and half the storage space. I'll just run through a very quick video that's available on YouTube. And this shows the installation of Panduit straps and cleats. You can see here in the simple version a double wrap MLT tie along with cushion sleeving and an installation tool. And this video shows how the MLT double wrap tie can be installed on this ladder rack. The cushion sleeve goes on, and then the cable tie fits through the slots in the rung. Remember, you can use a bracket if the slots aren't wide enough. And then just by using a battery operated tool, or a ratchet tool is available as well, pull the trigger until it reaches a predetermined tension and it cuts automatically. There are no sharp cutoffs. Half the cost, half the installation time, half the storage space. Using Panduit's straps, this is a slightly different version. And what we've done in this video is to show you how you can install straps, but on ladder rack that has no slots whatsoever. And all you need to do is use the Panduit bracket, which slots into place and tightens, and then using the cushion sleeve. And then in this case, we've used a triple wrap strap. You can use a double wrap strap, but the triple wrap gives added strength. It goes round, and then using the ratchet style installation tool, just tension, fold over, cut, and secure in place, leaving no exposed sharp edges. In terms of market applications, there are multiple markets that cleats need to be used, from data center, oil and gas, power generation, rail and tunnel. And all of these markets require the use of short circuit protection. In terms of success stories we've had so far, these are just a handful of them, particularly around the data center, but also around oil and gas, petrochemical, and shipbuilding. So, as a summary of the takeaways, it's worth remembering the following things. A cleat is quite simply a device that's used to secure cables. Panduit cable ties are every bit as effective as traditional styles of cleats. The relevant standard to use and the one that you need to be sure that every single manufacturer is complying to is IEC 61914/2021. We understand the effects of a short circuit event. We understand that Panduit has a simulation program, and we understand how to specify. We know that Panduit uses third-party testing. We know that Panduit uses a mathematical calculation, and we know that Panduit uses the simulation program along the way as well. When we talk about lowest installed cost, I'll go back to that catchphrase: half the cost, half the installation time, half the storage space. And finally, we know that Panduit has a cable cleat calculator, which means that instantly you can put in two pieces of information, which is number one, what is the peak current? Number two, what is the outside diameter of the cable? And with these bits of information, Panduit can recommend multiple solutions and at what distance between the fixation points the cable cleats have to be installed. That pretty much concludes the presentation for today. So I will open the floor now to any questions. Nicholas, do you have any questions come in while I've been talking? I apologize, I've been on a bit of a monologue here and I don't have access to the questions. Have you received any?
Thank you, Simon. I have indeed. First of all, I say you're on point as always, so thanks. I got two questions for you. First one is, would you say, can Panduit stainless steel cable ties be used 100% of the times to replace traditional stainless cleats?
Okay, there's a couple of parts to the answer of this question. So in addition to Panduit stainless steel cable ties and Panduit stainless steel strapping, we do also manufacture traditional style cleats, stainless steel trefoil cleats, polymer cleats, aluminium cleats and things like that. So in terms of, can the ball locking tie, the stainless steel double wrap ball locking tie, that tends to be used at the lower end of the scale of peak current, so up to around, and very because of the multiple variables that there are, up to around 70 to 90 kiloamps peak current, the ball locking ties can be used. In terms of the strapping, the double wrap and triple wrap strapping is every bit as strong as a traditional cable cleat. So pretty much in the majority of cases, you can use the strapping. So the answer is kind of twofold, towards the lower end of the scale for the ball locking ties and pretty much across the board for the strapping solution. Hope that answers the question.
Yeah, well, even I understand it, so that's probably a good thing.
Good.
Second question, what if I don't have the peak current data?
Again, slightly more complex. So if you have the, so the short answer to this is, whoever is specifying this will know the peak current. So somebody somewhere at the end user will know the peak current. If you don't have immediate access to it, sometimes people will say, here is the RMS, which is the lower version and not the peak current. You can actually, according to IEC 61914, you can actually use a multiplier on that RMS number. If it's below 40, you multiply it by a specific multiplier. If it is 40 and above, you can multiply it by a slightly different multiplier. That will give you that peak current. But we tend to insist that we get that peak number, that it's the peak number in kiloamps that you have to get to. There is like I say, a standard multiplier that can be used, but we prefer using that peak current. I hope that answers that question.
It sounds like it to me. And while you were answering this one, I got a third question for you.
Yeah.
Is there a difference between a vertical and horizontal installation? And if there is so, is the calculator capable of handling that difference?
Yeah, the short answer to that is no, there isn't a difference. So how to explain that one? The cable ties or the cable cleats themselves are deemed to be strong enough to hold the cable in place. But in terms of the short circuit event is a force that occurs from within the cleat. So it doesn't matter if it is on ladder rack, if it is vertical run on ladder rack, even if it is inverted, it is still the same force from within rather than anything else that is being tested. And 61914 also tests for axial and lateral loading on it. So the short answer is no, it doesn't make a difference.
Thank you. And that was indeed the last question I have received from the audience today.
Fantastic. If anyone thinks of any more questions, please contact Nicholas directly, who I'm sure he and I will be having conversations in the future. But I will leave you with half the cost, half the installation time, and half the storage space. And thank you very much indeed, everyone, for joining this call.
Thank you, Simon. And on behalf of Solar as well, I thank everyone who is logged on and attending. And I hope you have got some solid information that can bring your work forward as well. Thank you.